Good afternoon, sir.
Hello.
Hello, sir. Good afternoon, sir.
Good afternoon. Wait, let others also join. Acha, last class, what have we done?
We finished electrochemistry graph, sir. Mixture of acid versus strong base.
Okay, let them join also. I'll take my tea and come. Just a
Sure,
second.
sir. Sure, sir. So you can drink when you give us problems.
Okay, you want to solve some problems?
No, sir. No, sir. What I meant was whenever you give us problems, I always be like, sir, you go drink tea. Until then, we'll solve. So,
No, you ask for problems, I'll give you some problem.
okay, sir. Please, like conductance, sir, please. That cell constant and all. Okay.
All of you try this question. And meanwhile, all others also join, then we'll start the session. Done. Finished?
No, sir.
Why? You see, there's no current, right? For no current flow, what is the condition?
Potential is equal.
Equal potential. Means what? Means what?
Means no potential difference.
Yes. So that means what?
Sir, that equation is then a potential equation that you should equate.
What we can say?
Sir,
In terms of E cell, what we can say?
E cell is 0.
0. Right?
Yes, sir. I did it
What
last.
is the condition you need to apply?
Yes, sir.
First of all, what you do, you find out which one is cathode, which one is anode.
Okay. One sec, sir. 2 minutes. Sir, I had also posted on doubt. Could we discuss that also after this?
What? Amala, did you join?
Yes, sir.
Tell me the answer.
I'm trying.
Where is Niyati?
Sir, not getting, sir.
Okay. You know everything, then also you are not getting it. See, now answer me. Did you find out which one is cathode and which one is anode?
Sir, reduction thingy is cathode.
Which one is getting reduced?
The metal.
And why is that?
No. Metal is not getting reduced. Metal is getting oxidized. Sorry, the other one.
What is the other one?
The transfer of electrons.
But
Yeah, no.
what is the two electrode?
Standard hydrogen electrode.
Okay, तो एक तो hydrogen हो गया.
Yes, sir.
One half cell is hydrogen electrode. Other half cell is this metal.
Yeah.
Metal and hydrogen, which one will get reduced? That depends upon their reduction potential.
Yes, sir.
See, step by step you go. Step by step, you ask question to yourself and answer.
Okay, sir.
सबसे पहले, what are the electrodes? Metal and hydrogen. Correct. Now next question, which one is cathode, which one is anode? For that, what? The one which has the more reduction potential. will get reduced and behaves as
Cathode.
cathode, right? So which one
Yes,
has
sir.
reduction potential in this two?
Metal.
Metal, because metal, you see, it is given the potential, and when potential is given, it has reduction potential.
It's positive. Hydrogen electrode 0.
So yeah, so E naught value for M2 plus to M it is given, and that is 0.0295. Chalega, guys, I'm asking all of you.
Oh, yes, sir.
Correct?
I
Now,
didn't hear.
of E naught of H plus to H.
0.
Chalega?
Yeah.
Obviously, which one is cathode, which one is anode? The one which
Metal's
is
cathode.
cathode, and this one is anode.
Yeah.
Once you get this, what is E naught cell? Because in Nernst equation we need this, correct? E
E
naught
naught equals E cell minus 0.595 that log and out.
cathode minus E naught of
Log.
anode.
Yes, sir. Oh, okay.
Right? Terms you do not take care of. I asked you what is E naught cell, not E cell.
Yes, sir. Okay.
E naught cell is cathode minus E anode. Cathode is this, anode is this. Can I write down 0.0295? Okay.
Yeah.
What is the anode reaction? Fine.
So hydrogen loses 2 electrons.
What is the cathode reaction?
Metal gains 2 electrons.
Overall reaction is what?
Add those two, 2 electron gets cancelled.
See, I'm not doing anything. You are answering yourself. The point is you do not think step by step. That's why you are not getting it. Yeah, get reaction. And why we need this? Why we need this? Because we have to write Nernst equation.
Yeah.
In Nernst equation, if you write this, then here 0.0591 divided by 2 log of, here you should write on what should be there in the numerator and what should be there in the denominator. And for this, you need this product, this side h plus square divided by
M plus 2 square. No square, no square, yeah.
यहाँ तक did I do anything which you do not know?
No, sir.
Then what is the problem? Others, are you getting it? Advaita?
Yes, sir.
Niyati? Mehak, you there?
Yes, sir. Just joined.
Mehak, can you hear me?
Yes, sir. I just joined.
Yeah, where are you right now?
Sir, I'm in Assam.
Very good. Enjoy. Vidyata?
Yes, sir.
Okay.
Sir, is it 0 ml?
No. See, again you got everything I have done. Again you got the wrong answer. Why it is 0 ml? Now explain this. Why is 0 ml?
No, sir, I just substituted values. E cell should be 0, so 0.0295. That by 2 is 0.0295 log of that, so that should be 0.
What should be 0?
Huh, sir?
If it is 0, if nothing you should add, then there must be some E value. No?
No, sir, if it's already 0 in this state.
How it is 0? E naught value we have 0.029.
Yeah, that I substituted. You'll get that by 0.0295 equals 0.0295 log of that square by that.
Right. So what is log of this by this?
One sec, so where any pH?
If this terms comes to be 0, then also we have some potential, no?
But we should equate that to be 0, no, sir?
Bits to be 0.
E cell.
This to be 0, correct?
Yeah,
So for this, what is this term should be? H plus by M2 plus?
1.
That should be 1.
Oh, 1, not 0.
See. Wait.
Yes,
So,
sir, 1 only, sir.
just a second. Till now, whatever I have done, Shalini, are you getting it?
Yes, sir.
Now, whatever we have done, everything. Now I substitute the value. See, first of all, the concentration of M2 plus, if you need to find out, this concentration is not 1 molar. Venkat, there is a lot of noise from you. Okay. So concentration of M2 plus you cannot take as 1 because you have this solution of metal M, and initially the solution is 40 ml it is given. In this 40 ml, the concentration is 1 molar given, which is the number of moles here is 40 millimoles. It is present. Yes or no? But now since you are adding some solution into this, you are increasing the volume. So concentration will change. Yes or no? Because the volume of solvent is increasing. Solution is increasing, right? So concentration is not 1 now. So you cannot take 1 molar over here. But the concentration will be what? The number of moles initially present, that is 40 millimoles, divided by
1 plus X and then find X. That's it.
Divided by volume in ml, which is 40 plus V. If V ml we have added into this. Chalega?
Yes.
Chalega? So this is the concentration we have when we assume that we have added VML in order to make this E cell what?
0.
Because that is the condition for no current flow. Right? In order to make E cell 0, what I have assumed, we have added VML of solution into it. Now nothing you have to do, just you have to substitute the values into this nasty equation. So
Sir, it's B.
Huh?
B. Yeah. Total volume should be 400 ml.
Can I write this as 0.03?
Yeah.
This concentration is 1. This is 40. That is 40 plus V. Chalega?
Huh?
Venkat, a lot. So you see, when you solve this, we get 0.03 log of 40 plus V by 40 is equals to 0.029. Again, I am assuming this as 0.03 approximately. So to solve this, we'll get log of 40 plus V by 40 is equals to log 10. Because this 0.3 and 0.3 gets cancelled. So it is V is equals to what? 400 minus 40. So 360 we are getting approximately. So answer is the closest option we have, because we have made some approximation here. So answer is this. Tell me, was there anything that you do not know?
No, sir.
Then what is the problem? Why you could not get this? Because you see, the problem solving is what? It is the step-by-step process. Okay, step-by-step process. You need to think one by one. The problem is that when you read out the question, you directly start thinking about the answer. What should the answer be? Okay. But it is very like a stepwise you need to think. If this is given, then what should be anode, what should be cathode? Because once, and the thing is what, it's not like very broad. It's not like organic chemistry, where you have to think about some aesthetic hindrance, some stability factor, some exceptions things are there. It's not like that. It's very confined. Only one thing you need to do, and what is that? Nernst equation. Finish. You need to apply Nernst equation. You know the condition of no current flow. It is E cell should be 0, right? So you need to find out E naught cell. E naught cell, if you want to find out, you should know what is cathode, what is anode. So first you'll find out cathode and anode. And how do you find out cathode and anode? Depending upon what? The values, reduction potential. So we'll identify cathode and anode. We'll find out E naught cell. And then we'll assume the volume so that the E cell will be 0. Okay, it is not tough. These questions are not tough. These are very logical. You need to think a bit on it. So this kind of, thought process, step by step, you will develop once you solve 50 to 100 questions in a chapter. And that's why we say practice is very important. Okay, did you understand this?
Sir,
Or should I give you some more lectures?
sir, sir, I also sent one doubt, sir. Could we discuss that?
No.
Okay, sir.
Personal
No,
doubt
see,
after that. Wait, I did not see a doubt.
not you to you, sir. I'll send it to you, sir.
On the group.
Yes, sir.
I'll see that later. Okay, so करेंगे बाद में. Yeah. One of the question you sent on the group.
Yes, sir.
I did not read it properly, but I saw one question of maybe related with conduction and things, right?
Yes, sir.
I saw that. I did not read it. I will do that. I'll send you the solution for that. Okay.
Sir, I sent it to you now. Could you see it? It's confusing. I got confused in that, sir.
So when is here and then added to water. Containing water, and that is specific conductance is given. This 500 gram of NaCl was taken, was then added to water. The specific conductance after the addition of NaCl was found to be this.
Sir, I'll tell you my thought process. Step by step, I'll tell you.
Tell me.
Okay, sir. So let it be V ml. That volume of that vessel be VML. The number of equivalents will be what? How much is given? 500 by 58.5. That's weight, given weight by equivalent weight. That's like 8 point something. So volume containing for 8.5 it's V, then for 1 it's V by 8.54. So then specific conductance of NaCl, that is only due to Na plus and Cl minus, is that thing minus that thing. So that thing is 3.1 into 10 power minus 5 minus 2.5 into 10 power minus 5. After this, I'm not sure what to do, sir.
See,
Yes, sir.
No. The volume is not the capacity of the vessel is fully filled. Fully filled. So its capacity is V. Density is not given, no?
No, sir. It's filled with water, contains water only is given, but if you're adding NaCl, density will change.
That's what. So density should be given, no? For NaCl.
So on the other hand, I don't think the question is wrong. It's from RC perfectly. So
okay,
I'll
see this. I'll see this.
Okay, yes, sir.
Density is given, then we can talk about volume of NaCl plus water density. We know, right?
Yes,
so
sir.
We'll talk about the volume of this. So then we can talk about the capacity because it's fully filled with 500 gram of NaCl.
But one thing I know, if it's big, I guess, like in physics, we know a large sheet of wire, a large metal sheet means area is infinity and stuff, right? So big, I thought volume should be infinity, but I'm not sure. After this, I stopped, sir. I couldn't proceed. Like you could, if you want, assume volume to be infinity. Infinite dilution thingies.
No. Is there an option given?
No, sir. Subjective.
Which book it is?
R.C. Mukherjee.
Achha, theek hai. I'll see. Dekho.
Yes, sir.
ठीक है, we'll see this. Let it be now. मैं करके I'll send it.
Okay, sir.
ठीक है. One more question I want you to just do this one quickly. Both quickly you do this.
Sir, 14A.
Next one.
3 minutes, sir, please. I'm doing. This one I don't want to mess up, sir. I'll take my own time.
First one is easy, right? All of you have done.
So do you want to see working? There's not much for this. Peaceful only.
There are more than 5,000 photos I have in my phone.
Okay, sir.
Them are useless now.
Okay, sir.
You understood? No, these kind of questions I get almost every day. And
These are peaceful, sir, not very harmful. But I'm just thinking carefully, writing steps and like CBSE, like I'm writing for second one. I'll show you, sir. 2 minutes.
the pattern is like this. Given data, you write down first. Right. Then formula to be used, you write down and then you substitute that. Each step you explain it properly. That is it.
Yes, sir. Just a minute, almost.
Okay, 14th one. What like you need to apply into this one?
E1 equals E2.
Yeah, because equal current is passing through. So equal equivalent will get deposit. Okay. So if you see the formula here, M is equals to E IT by 96500. So this 96500 is nothing but the Faraday of charge. So when this charge is equal, because equal current for equal time, so this will be equal. So when equal current passes through, so M by E is the ratio we have for two different electrolytes. Right? M is mass, E is equivalent base. So M by E is the number of what?
Equivalence.
Number of equivalents.
So 15 is A, sir.
Correct. So number of equivalents of hydrogen, that would be equals to the number of equivalent of copper. That is what you need to do. So number of equivalents of hydrogen is 0.504 given mass divided by equivalent mass of hydrogen is 1 is equals to the mass of copper we need to find out. Equivalent mass is 63.5 divided by 2.
2.
Cu2.
So, yeah.
So this becomes what? This becomes almost 0.25. 0.25 into this is 1/4 of this. So 1/4 is around almost around 16 grams.
Yeah.
I've seen this question 15.
A, sir. A.
A.
Sir. Cathode hydrogen, anode oxygen.
Okay. How it is possible that you got all the right answer? Okay. It is never possible.
Sir. So sometimes miracles happen, sir. कभी कभार fluke हो जाता है.
Did it correctly actually. Cathode is hydrogen, anode is oxygen. That's what
Yes,
I
sir.
did. But you marked the wrong option, so you got -1 again.
Now I realized it, and since this is not pen paper test, I changed it afterwards, sir. It's in computer basis, so I changed it, sir.
I told you this is the product of electrolysis. So you need to understand that, which ion will get oxidized or reduced. So first of all, what all ions are present? Ions are Na plus, H plus, and
OH minus, SO4 minus 2.
and OH minus. Okay, so these two
Yeah.
will go towards anode. These two will go towards cathode, right? And we know the reduction potential of hydrogen is 0. And this, the value I do not know, but it is in negative. Yes or no? Because
Yeah.
alkali metals are on the top, right? Lithium and then sodium. So this is negative. This is positive. Positive means its reduction potential is more. It means H plus will get reduced and evolves what?
Hydrogen.
Yes. So at cathode, hydrogen evolves, right? So इसमें तो hydrogen है ही नहीं, ignored. यहाँ पे it says at anode hydrogen evolve, ignore Mari. Who's the answer? Okay.
Yes, sir.
One thing you must take care of, if you have sulfate ion and hydroxide ion. So at high concentration, this will get oxidized. High concentration. At low concentration, this will get oxidized. And when this gets oxidized, it gives O2. And here we get S2OH2 minus peroxysulfuric acid.
Sir, but oxidizing potential of SO4 2 is very small compared to water, no, sir?
That also you can say, but depends upon the concentration also.
Yes, sir.
Done? Understood?
Yes, sir.
So next we have to start with P block elements. Okay. Group 15 we are going to start, and group 15 is what?
Nitrogen, phosphorus, arsenic, antimony, bismuth.
Yes. Okay, so for all these P block elements, first of all, for preparation, NCRT you must have to do. And once you finish NCRT, theory line by line you have to study. Okay, then you can go for other books like O.P. Dandon, Singage, whatever you have. But NCRT you must do, right? And then all these P block, we are going to discuss with the preparation, some general properties, okay, of elements, not all elements, at least first two, like first two max to max, not third element. Like for nitrogen family, we'll see for nitrogen and phosphorus, right? Compounds of nitrogen and a little bit compound of phosphorus. That is what we need to do. Okay. So nitrogen, we know nitrogen forms halides, phosphorus forms halides, PCl3, PCl5 we have. Trihalides, pentahalides. Okay. Hydrides also it forms NH3 type, PH3, all these hydrides it forms, right? There are oxides of nitrogen, different oxides it forms. Compounds of nitrogen, we have nitric acid, HNO3, the most important one. Okay, phosphorus, compounds we have PH3, phosphine gas. Okay, the preparation of phosphine properties, and then oxo acids of phosphorus. These are the things we have to study over here. Okay? So, the general properties that we have, like what happens with electron ionization enthalpy, what happens with atomic radius, ionic radius, as we go down the group left to right. Okay. What happens with metallic property, electronegativity, what happens, melting boiling point, what happens. Okay. All these things are more or less similar to all the groups. Even whatever you have done for group 13 and 14, it is similar over here, right? So for group 15, I'll discuss all those things again, right? But 16, 17, we won't repeat those things. So, are you getting it? Means whatever
Yes, sir.
common, like for example, electronegativity as we go down the group, क्या होता है? It decreases.
Decrease.
Correct?
Yes.
So, this is because some of you were not there last year, so I want you to know discuss all those things. But for next class, group 16 and group 17, we won't discuss those common things. Like down the group, if you go, this happens. Whatever is common, I won't discuss. Yes, obviously, whatever thing is exception, right? If there change in property is there, then I will mention that. Otherwise, it is same, so I'll just leave that. I'll just tell you, and then we'll move on to the other topic, right? So, we'll start with P block elements, group 15. And group 15, we also call it as what?
Pnicogens.
Why?
Nitrogen family. Nitro, Ni, N, all same things, sir.
Why Nicogen? What did you say?
Pnicogens.
Why Nicogens?
Nitrogen, sir. Nitrogen is the father, phosphorus is the mother, all other families, sir.
Who told you this thing?
No one told me, sir.
It's just you are giving all this logic on your own. Like this kind of probably the logic would be. That's what you're doing. I understood. So it is nitrogen family, right?
I told you, sir.
Nitrogen family, we call it as Nicogens. And what is the spelling of Nicogen?
P-N-I-C-O-G-I-N-S. G-E-N-S, sorry.
Nicogen. Why Nicogen? Nicogen is what? Nicogen is the Greek word. Okay.
Oh.
Which derives from Nicomix. Okay, Nicomix means suffocation, right? Means when you inhale this, you will be suffocating. Like you cannot breathe properly in that case, right?
Like coronavirus.
Huh?
Like coronavirus, COVID.
Like this thing, styrene. The thing happened day before yesterday in Visakhapatnam. You know that?
Yes, sir.
Styrene gas leaks, and so many people, like 15-20 people died. So those kind of stuff is very. Where we use styrene?
Sir, that Amazon packing.
Styrene
That TV all comes, no, that one.
Is a monomer actually. We'll see this in polymer chapter. The polymer of styrene is polystyrene. Polystyrene, you heard polystyrene? Right, so polystyrene is made up of styrene. The monomer is styrene over there. Okay, so that's what the thing. But anyways, that is not the concern here. So Nicogen is the Greek word derived from the Greek word Nicomix, which means suffocation. Correct? But this they are not going to ask. Okay, what all elements we have here in nitrogen family? We have nitrogen. Okay, nitrogen, phosphorus, arsenic, antimony, and bismuth. Atomic number of nitrogen. Atomic
7.
number is 7, For phosphorus, it is
15,
then
33, 7, 8, 18, 51, 69, I guess.
huh?
36, 87, sir.
87 or 83.
87, I'll check 7 sec.
I think it's 32 we have to add, no?
I have this book. This math.
32 we have to add, I think.
Yes, sir, 32, sorry.
8, this is 8.
83, correct, sir.
That's what I said, 83. So you see this difference is 8, the atomic number. And here it is 18. Here it is again 18. And here it is 32. 8, 18, 18, 8, 18, 18, 32 are the magic number of this group. Right? These numbers helps to determine the atomic number of the elements present in the lower periods. Okay. So 7, 15, 33, 51 and this. Electronic configuration of nitrogen is 1s2, 2s2, 2p3. Since the last electron enters into the p subshell, that's why this is p groups, p block elements. Okay. For phosphorus, the outermost configuration is
something PS3.
PS2 3p3 because it's third period. Second
Yes, sir.
period 2s2 2p3, third period 2s2 3p3 and so on. Fourth period, fifth period and so on. Correct? So this is the basic thing. Now, if you see there is electronic configuration of these elements, electronic configuration,
NS2 NP3.
outermost electronic configuration is NS2 NP3. The first property is this, right? NS2 NP3. So you see it has half filled configuration. Yes, it has half filled configuration NS2 NP3. 3 electrons present in the p subshell, right? And there is one electron each, right? That's why if you compare the other things like stability, first of all, so stability of these elements is higher than to that of other elements which has different configuration. We are not talking about the fully filled configuration. Half filled, fully filled one side, and for all those elements which do not have these configurations, the stability of these elements is more than to the other elements. Okay, so each p orbital has one electron each. One electron each. Correct? Half filled configuration. Now this half filled configuration affects the property of these elements. Because obviously, first thing, if you try to remove an electron, right? So since the stability is more, so we have to provide what? More energy.
More energy to do stuff.
So point I'm trying to make is what? Because of the electronic configuration, or this electronic configuration affects the property of this elements, these elements. Chalega? How it affects, we'll see that one by one. Correct? So first thing we have discussed, electronic configuration. The second property you write down. The second one is atomic and ionic radius. Radii. Okay? Write down. As we go down the group, what happens?
Both increases. I don't know if there's any exception, but
Write down
technically, sorry, sir.
As we go down the group, atomic radius and ionic radius increases. Atomic radius and ionic radius increases. Okay. As you go down the group, you see what happens. The electrons are going into higher energy shell. You see, from second to third, third to fourth, fourth to fifth. It means we are going away from the nucleus, correct? And that's why the atomic radius increases. And same reason we have for ionic radius. This is though down the group. Right down, as you go left to right, what happens left to right?
Decreases. Atomic radius decreases in a period. Yes, sir.
Atomic radius decreases. And what is the reason for that?
So more electrons.
Atomic radius decreases because of effective nuclear charge. Write down, as we go left to right, atomic radius decreases because of effective nuclear charge, right? These are the general trend, right? Left to right, atomic radius decreases. Top to bottom, atomic radius increases. Write down, next line to this, the atomic radius of the elements of group 15 is lesser than to that of group 14. That's what we have written. Right? So because of half filled, it does not alter the atomic radius thing of it. Okay? Group 15 is more, group 15 is less, group 14 is more. Okay? Next, write down ionization enthalpy. What happens ionization enthalpy? It is the amount of energy required to remove an electron from the outermost shell. Right? So if the size increases,
decreases down the group.
The electron and the nucleus decreases, and hence the enthalpy, ionization enthalpy decreases. So write down, as we go down the group, the ionization enthalpy decreases as size increases. Okay? Down the group, ionization energy decreases. Left to right, what happens?
Increases like crazy.
The ionization energy
Increase muddy.
increases. Why? Because the size decreases. Difficult to remove electron from the valence shell. But if you compare nitrogen and oxygen, which one has more ionization energy?
Nitrogen.
Why nitrogen? Because it has half filled.
Half filled.
So this is the exception. Because this has half filled configuration. Now you see, with the help of this ionization energy, we can conclude 2-3 points here. Okay. Listen to me. Don't write anything. Okay. As we go down the group, ionization energy decreases. Right? Means tendency to release electron is more. So other way, what we can say, tendency to accept electron is less.
Less.
This means what? Electronegativity decreases. As tendency to release electron is more, it means it has more electropositive nature. So electropositive nature increases. Electropositive nature means what? Tendency to release electron, and tendency to release electron is nothing but the metallic nature. So metallic nature also
Increases down the group.
increases.
Yes, sir.
All these three properties we can explain from this particular thing, that is ionization enthalpy. So quickly write down the fourth point, electronegativity. As we go down the group, electronegativity decreases. Okay. Metallic character. Metallic character is a tendency to release electron. So as we go down the group, metallic character increases as ionization enthalpy decreases. Coming, just a minute. Okay, done.
Yes, sir.
Down the group, metallic character increases. Metallic character is nothing but the tendency to release electron. Okay, so we can correlate all these property to memorize this. Okay. Now the other thing here, nitrogen and phosphorus are non-metals. Okay. Arsenic and antimony are metalloids, and bismuth behaves as a metal. These are non-metals.
Metalloids.
Okay. So metallic character is nothing but electropositive nature. So electropositive behavior also increases down the group. In this only you write down. The electropositive behavior also increases down the group. Done?
Yes, sir.
Now when we talk about the physical state, nitrogen at room temperature, nitrogen exists as a gas. Okay, write down at room temperature, temperature, N2 is a gas. And write down N2 molecules are held together by weak van der Waals forces. N2 molecules are held together by weak van der Waals forces.
Sir, any gas for that matter, no, sir? Oxygen, fluorine, and all.
Yes, we can say, but the van der Waals forces will be different in all the gases.
Yes, sir.
But yes, they held together by van der Waals forces.
You only taught us in chemical bonding, sir.
Yes. So next, write down nitrogen gas has very high bond dissociation enthalpy. Bond dissociation enthalpy. Why very high bond dissociation enthalpy?
Half filled, stable, and strong, and all.
No. N2 gas में कहाँ half filled है भाई?
Sir, 2p3, sir.
Why? N2 जब हो गया तो 3-3 bond बना लिया ना, triple bond.
A bond order is high then.
Also small, sir. That's why.
Yeah, N2 the size is small and they held together by a triple bond. The nitrogen atom held together by triple bond, right?
POS3, yeah.
Which is the strong bond we have, right? Hence, the bond dissociation enthalpy of nitrogen is very high and it behaves as an inert gas at room temperature. Inert, it is not like the noble gas, okay? But since high dissociation energy is there, so its reactivity tendency is very less. Right, now nitrogen has ability to form p-pi multiple bonds because of their small size. Because of their small size. Next line. Other elements does not form multiple bonds. Multiple bonds means what? Pi
Double,
bonds.
triple, and all.
Huh?
Double,
Multiple
triple,
bonds.
and all.
No, multiple bonds means pi bonds. Only nitrogen has tendency to form multiple bonds. That's why nitrogen atom combines together by lateral overlapping. The orbitals goes under lateral overlapping and forms N triple bond N like this. But this kind of multiple bond is not possible in other elements because as we go down the group, the size increases. Okay? So phosphorus, the distance is more over here, and hence the orbital are not close enough so that the overlapping, lateral overlapping takes place. Right? For lateral overlapping, elements has to come closer. Right? And hence it is observed only in nitrogen, but all other elements does not form multiple bonds. Okay. Next, write down chemical properties. Chemical properties. Write down the elements of group 15. The elements of group 15 can easily form bonds. Can easily form bonds by either electron transfer or electron sharing. form bonds by electron transfer or electron sharing. And they shows oxidation state from +3 to +5. +3 to +5. Write down, they also have tendency to form negative oxidation state.
So could you repeat the +3 and +5 oxidation state and negative oxidation state, right?
They also shows negative oxidation state. So when does this show negative oxidation state? See, the oxidation state thing you can explain on the basis of their electronic configuration. Yeah.
Oh, yes, sir.
Electronic configuration is the outermost electronic configuration is NH2NP3. So to gain octet, what it can do? Either it can accept 3 electron,
Or lose 5.
or it can lose 5, or it can lose 3 electron, or this can also lose all the 5 electrons present in the outermost shell. So possibility is what? It can show -3, right? It can show +3, it can show +5. -3 to +5 it's possible. This is the range we have actually. Right? -3 to +5 it can show. That is the range we have actually. Write down. Besides -3, nitrogen can also show -2 or -1 oxidation state.
So that's anyway there in the range only, no, sir? -3 to +5, that's also covered. No, sir?
Phosphorus is then the range. But what happens actually, in NH2 hydrazine, I have given you 2 points in one common line, that's why you're asking this. Here it is -2, correct? Nitrogen. This compound is also formed by phosphorus, PH2, -2 possible. Okay, if you see hydroxylamine, NH2OH, nitrogen oxidation number is -1. But nitrogen does not form this, sorry, phosphorus does not form this compound.
Yes, sir.
For phosphorus, -1 oxidation state is not possible. But nitrogen shows -1, -2, all those oxidations is possible for nitrogen.
So just a second, sir. So what's the second thing called? PH to PH2? That's called something.
PH2 is what we can say. PH2 is PH3 is phosphine. So I think we can say diphosphine. Diphosphine is possible because PH3 is for phosphine.
Oh,
PH2 diphosphine, we can say.
yes, sir. Hydroxyamine. Done, sir.
Next point, nature of bonding. Nature of bonding. Write down, in majority of these compounds, of these elements, in majority of the compounds of these elements, write down, in majority of the compounds of these elements, the bonds are covalent right? Covalent. Nitrogen and phosphorus. Nitrogen and phosphorus predominantly forms covalent bond due to their small size.
So forms nitrogen, phosphorus forms.
Predominantly forms covalent bond.
Oh, predominantly form. Okay. Forms covalent.
Forms covalent bond due to their small size. And the tendency to form covalent bond decreases down the group
Sir, could you repeat that sentence?
from the beginning.
No, the tendency to form.
And the tendency to form covalent bond decreases down the group as the size increases. Means down the group, what we can say, the ionic character increases.
So ionic bond formation also tendency increases.
What?
So for tendency to form ionic bond also increases.
Yes, covalent character decreases, ionic character increases. Okay. So all these are general trends that we have discussed. Now the important point here is the compounds that is formed by these elements and their chemical reactivity, right? Write down formation of compounds and their reactivity. This you have to memorize. The first types of compound we are going to see is hydrides. Write down all elements of group 3 forms hydride of MH3 type. MH3 type. Okay? Let's see how does it form. So first of all, what happens? The s orbital has 2 electrons and p has 3 electrons. Okay, so all these 3 orbitals goes under hybridization and forms hybrid orbital, and these are sp3 hybridized orbitals. Okay, then hydrogen comes up, right, provides its electron to the unpaired electrons here, the 3 orbitals, and forms a bond, right? So first of all, what is the hybridization for this type of hydrides?
sp3.
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 Bond angle
109.28. Eh? Okay.
Bond pair is 3, lone pair is 1. Lone pair, bond pair repulsion, no?
Ah, yes, sir. Yes, sir. 1 degree-ish reduction.
9 when there is no lone pair. Ideal case.
Yes, sir. Forgot that.
Okay? This is the general properties. So structure कैसा हो जाएगा? The structure is this. Has 1 lone pair on this metal and 3 hydrogen present like this. Right? 3 bond pair and 1 lone pair. Hence the bond angle reduces. Now the various properties of these hydrides we'll see one by one. So first thing is the bond angle. Bond angle, as we go down the group, the bond angle decreases. So bond angle is maximum in NH3. Then we have PH3, ASH3, SBH3. All these trends are very important. Right? Whatever we'll do now onwards, those are very important. Okay? Trends of various compounds. Okay? NH3, PH3, ASH3, SBH3, and BIH3. See the bond angle, this depends upon the size and electronegativity. Size and electronegativity of the central atom. Central atom. Electronegativity of the central atom. See what happens due to small size and high electronegativity. So this metal that you have here, what it does, it attracts the electron pair towards its side. Clear? Okay. This bond pair will be shifted towards the metal, central metal, right? Yes or no?
Yes, sir. Yes, sir.
So when these electron pairs are going towards the atom, so they are coming closer, right? You see this? Right? So when they are coming closer, so they repel each other. That is why the bond angle here increases. So with electronegativity of the central atom, bond angle increases. That is what the general trend also we have. As the electronegativity of central atom increases, the bond angle increases. There are a few exceptions, but more or less this is true. If you see the exact value of NH3 here, the NH3 has 107 degree, 8 minute. For this is 93.6. For this is 91.8. This is 91.3 and this is 90. So you don't have to memorize the values, but trend you must remember.
Sir, but why will electrons want to go near the metal, sir, as size increases?
Yeah.
Why do electrons want to go near metal, sir, as size increases?
When electronegativity increases, this will drag the bond pair of electron towards the side.
Yes, sir, but size also will increase accordingly. So more or less it gets compensated.
Size increases, so electronegativity decreases.
Yes, sir.
So the tendency will be less.
Yeah, but distance is higher. So
what distance is higher? Between the metal and hydrogen, right?
Yeah.
That's what it is. Distance is higher. The electrons are far apart. And the tendency for the electron pair to go towards the metal atom is also less because less electronegativity.
Yes, sir. Oh, yeah, correct, sir. Got it, sir.
The electron pair goes towards the metal,
Yes, sir.
Electronegativity. So they obviously the electrons are coming closer. You see, they are converging on one point. Yes or no? The electron pairs.
Yeah,
Right?
sir.
They are converging on the metal atom. Right? So in this way, what happens? The distance between the electron pair is decreasing.
Yeah.
Repulsion is increasing. So in order to minimize the repulsion, they'll expand the angle, the bond angle.
Oh, okay. Yes, sir. Got it, sir.
So mutual, balance will be there because this also will push this electron pair. ये इसको push करेगा नीचे. ये इसको. This
Yes,
lone
sir.
pair will also push this electron pair down. और
Yes,
ये
sir.
को push कर रहे होंगे यारे हट जाओ.
Yes, sir.
Okay. So जहाँ पे the balance is where the mutual repulsion and attraction forces like counters each other completely. That is the bond angle here.
Yes, sir.
Okay? And hence, so basically, if you consider all these things, you'll get confused. So what you need to keep in mind, as the central atom electronegativity increases, the bond pair of electron is moving towards the metal. In order to they are coming closer to each other. To minimize that repulsion, the bond angle increases.
Yes, sir. Got it, sir.
See, one point I forgot to give you. Before this hydride, the general trend is there, no? There only you write down melting point and boiling point. It is important, and I forgot to give you this. Right? It's not about hydrides. We're talking about metal. So you have some space, you write down 3-4 lines it requires. Write down melting point and boiling point. Write down. It does not follow the regular trend. Right, on the melting point first increases from nitrogen to arsenic. Melting point first increases from nitrogen to arsenic and then decreases to antimony and bismuth.
Why, sir?
Wait. Order of melting point is this: nitrogen, phosphorus, this is the exact order. Irregular trend, hence it is important. Write down the melting point. I'll give a detailed explanation of this. Okay. Write down the melting point increases down the group, but the unexpected decrease in melting point of antimony and bismuth Okay, Dheeraj, no problem. Okay, so the unexpected decrease in the melting point of antimony and bismuth is because of the inert pair effect.
Oh, those two last thingies.
Yes.
S
Due to inert
subshell.
pair effect, these elements forms 3 covalent bond instead of 5 covalent bond. Right? More covalent bond, more melting point. Right? These elements forms 3 covalent bond instead of 5 covalent bond, and hence the melting point decreases. So down the group usually increases, but in case of antimony and bismuth, inert pair effect comes into the picture, and that decreases the number of covalent bond forms, and hence the melting point decreases. Chalega?
Yes, sir.
Right on the next line, the boiling point increases regularly down the group with the exception of phosphorus and nitrogen. So down the group increases boiling point. Boiling point basically atomic mass increases, boiling point increases. Okay? So nitrogen, then phosphorus. This is the boiling point order. But there is an exception. Exception is what? Phosphorus comes first and nitrogen comes second. In the last and nitrogen the second. So P is this, is the exception. This is the correct order here of boiling point.
Sir, but we have solid phosphorus, sir. Do we? White phosphorus, red phosphorus in matches and all. That's white, red phosphorus, and at that temperature, nitrogen is gas, but phosphorus is solid, sir.
Because of covalent bond.
Yes, sir. Yes, sir. Like according to this order, nitrogen is has a higher boiling point than phosphorus, right?
Why? That's
Correct,
what
sir.
I said. Usually down the group increases, right?
Yes, sir.
Down the group increases. So,
Yes, sir.
but nitrogen has some exception into this because of small size of nitrogen. Its boiling point is slightly lesser than to that of phosphorus. Another thing is what? In nitrogen, there is van der Waals forces, right?
Yes, sir.
Weaker forces. So it can convert into the gas easily.
Nitrogen is higher, sir. Nitrogen is higher.
I'm telling you that trend, usually trend should be like this. The group, if you go, it increases, right? Like
Yes, sir.
But nitrogen is exceptionally more than to that of phosphorus.
Okay, understood, sir. But in room temperatures, in our puja room and all, we have matches, right? That is made of red phosphorus. Red phosphorus is solid there, and this guy, nitrogen in that room is gas only. So
that's why it exists. No, if boiling point, the thing is, boiling point of nitrogen is more, right? To that of, there are many things. Actually, you see, when you have an atom, okay, we are, like I said, it is an exception.
Yes, sir.
That's why. Otherwise, if there is any possibility, I would have explained this. If it is given in the book or anywhere, I would have explained this, that this is the reason.
Yes, sir.
In the book also it is written that this is an exception. Why?
Yes, sir.
Because there is not like only one factor which affects the property of the molecule. Like you see,
Yes,
the
sir.
electrons also affects the property, right? Size of the atom affects the property,
yes,
right?
sir.
The orientation of electron in the orbital affects the property. So what property, and collectively all these factors gives the property of an atom.
Yes, sir. Okay.
Factor dominates when, depending upon that, we have the order over here.
Oh, okay, sir.
Other factor, you will get the another result. And for the same thing, with other factor, you'll get different results. So two different results, like we have done one question that is, the Lewis acidity of BF3, BCl3, etc. Correct? Lewis acidity of BCl3 is more than to that of BF3. But if you consider the electronegativity factor, it has more tendency to accept electron, correct? BF3.
Oh, yeah, yes, sir.
So it should have more Lewis acid behavior, more tendency to accept. That depends upon the electronegativity factor, right? But actually the order is what? The order is ulta. BCl3 is more better Lewis acid than BF3 because the factor here is back bonding. Right, so that is what I'm trying to explain you. There are many factors which affects the property of an atom, a molecule. We are studying only those factors which dominates and gives the desired results. So here in inorganic chemistry especially, everything is already there, already defined. We study the property first, if I give you one very simple example, oxygen is diamagnetic or paramagnetic?
Paramagnetic.
Paramagnetic.
Yeah, yes, sir, para.
Right, paramagnetic. But whether you know this fact that oxygen is paramagnetic or diamagnetic, imagine the moment when this particular property was discovered, that oxygen is actually paramagnetic. Right.
Yes, sir.
At that point of time that we came to know about the magnetic behavior of oxygen. But oxygen is paramagnetic from the moment it exists on the earth.
Yes, sir.
Right. The point is we study the property first in inorganic chemistry. We study the property first, and then we try to explain that particular behavior or property of an element or molecule with best possible explanation that we have.
Okay, sir.
If we could not do it, okay, we say what? This is an exception.
Yes, sir.
So it is other way.
Yes, sir.
In nitrogen and phosphorus, like you rightly said, that phosphorus exists at room temperature. Correct?
Yes, sir.
If boiling point is less, ideally what happens? Ideally, phosphorus should burn into the atmosphere. But that is not happening. That's why it is an exception.
Okay, sir.
So that is the most difficult part of inorganic chemistry, that you should know that what factor you have to think about when.
Yes, sir.
Right. So when you study this, when you keep on revising these things, then only you will get to understand that at this point, this factor is the picture, and we have to think about this factor to understand the concept.
Yes, sir.
Discuss many things. You will understand this point, whatever I'm telling you. I'll show you this example. That one factor gives you different result, another factor gives you different result. Okay? So
Yes, sir.
we should think about to determine the property of the molecule. The factor which dominates, right? And by looking at the element and molecule, we cannot say, okay, this factor is dominating.
Yes, sir.
We can only say by the research, like whatever research we have done onto those elements or molecules or compounds, and we observe, okay, this particular element behaves like this under this condition. So
Yes, sir.
behavior is this, so this should be the reason for this behavior. Like this it goes.
Okay, sir.
Correct? So melting
Yes, sir.
order I have given you, it is an irregular trend. Boiling point, it is somewhat, similar. It increases down the group with the exceptions of nitrogen. Okay. Since there is an irregular trend, so this 2 order is very important for your exam. Okay. Wherever in organic chemistry you observe irregular trend, those things are important. Like, so we have discussed bond angle. Bond angle is also important of hydride. So this is not the part of hydride things. I'll just cover this in a box. Okay. So we are discussing about hydrides. So hydrides, we have discussed what? We have discussed the bond angle. Second point you write down. Second point for hydrides, it is melting point and boiling point of hydrides, MP and BP. Okay, write down. The melting point of NH3, I'll give you the order first, wait. The order of melting point is maximum for NH3. Then we have BiH3. Okay. And then we have SbH3. Then we have AsH3. And in the last, we have phosphorus. So how do you memorize this? From phosphorus to bismuth, hydrides that we have, melting point increases, but NH3 will have the highest melting point. The reason is intermolecular what?
Hydrogen bonding.
Hydrogen bonding. So NH3 has the highest melting point because of intermolecular hydrogen bonding. But general thing is what? Down the group, if you go, melting point increases. So you can write down the group, if you go, melting point increases with the exception of NH3. NH3 will have highest melting point because of intermolecular hydrogen bonding. Okay. See, we are talking about melting point, right? Means what? Solid to liquid conversion we are talking about, yes?
Yeah, sir.
Lipinga.
Sir?
Lipinga.
No, sir.
Melting point means what? Solid to liquid. And boiling point is
Solid
what?
to liquid.
Huh? What? Okay. So we have two different state here. Solid state we have when you're talking about the melting point. Boiling point, we have liquid state. So in solid state, what happens? There are actually two factors which defines this order here of melting and boiling point. The two factors are molecular mass and van der Waals forces. Correct? So when there is solid state, so in solid state, what happens? The van der Waals forces are not so strong, right? So van der Waals forces are not so strong in solid state as they are in liquid state. समझ में आ गई बात?
Why, sir? Like in graphite, it's good only, sir. Like I know, but why is it different here?
Wait. What I
Yes,
said
sir.
that in solid state, the van der Waals forces are strong. See, if why the molecule exists in solid state? Because of strong intermolecular forces, correct?
Yeah.
So van der Waals forces are what? It is the weakest force we have.
Yes, sir.
The molecules of solid cannot have van der Waals forces because it is defined for the weak forces, like in
Okay.
noble gas, correct? So in
Yes,
solid,
sir.
what happens? In solid, we have van der Waals force is not the reason to define the melting point of solid because it is not that strong in solid state. Fine.
Yes, sir.
But in boiling point, we discuss about van der Waals forces because it is strong in case of liquid or gas. So van der Waals forces is a factor over here in boiling point. But in melting point, van der Waals is not the factor. But the factor here is in solid state is hydrogen bonding, we can say, or we can say molecular mass. Hydrogen bonding is there in NH3, but molecular mass in all these factors here. So what we can say, as we go down the group, the molecular mass increases, melting point increases, ignoring the van der Waals forces. Okay? But in case of NH3, what happens? It has intermolecular hydrogen bonding. So because of that, its melting point is maximum. So reason for this increase from phosphorus to bismuth, the reason for this increase is what? The reason for this increase is the increase in molecular mass. More molecular mass, more melting point. For NH3, the molecular mass is the minimum, but it has intermolecular hydrogen bonding, which dominates the molecular mass factor also, and hence the order is this. So what I'm trying to tell you that in melting point, we'll discuss about the molecular mass or atomic mass, because hydrogen is same in all the molecules. So heavier the atom, more will be the melting point, right? If hydrogen bonding is there, then we consider the max. When we have boiling point, so in case of boiling point, the factor we have is what? Write down, the factor we have is van der Waals forces. Write down, the boiling point order is this. Boiling point order. It is maximum for BiH3. Then we have SbH3. Down the group increases. But here in between we have NH3, ASH3, BH3. So what is common in both order, that the boiling point and melting point of pH3 is minimum. Done?
Yes, sir.
So this is
Yes, sir.
So this is the order of boiling point. BP of boiling point, because in BiH3 what happens? We are considering van der Waals forces, right? So as molecular mass increases, the van der Waals forces also increases, right? So general thing is what, down the group if you go, van der Waals forces increases because of the increase in molecular mass. Hence boiling point increases, right? But in NH3 again what happens?
Hydrogen bonding.
Hydrogen bonding in NH3 is weaker in liquid state or in gaseous state than in solid state. That's why the hydrogen bonding is not the major factor. It is not dominating all the other factors, right? So in NH3, the hydrogen bonding is weaker in liquid or gaseous state, but it is maximum in solid state. That's why in solid state melting point, hydrogen bonding is the dominating factor. But here it is the factor, but it does not dominate the molecular mass for these two atoms. Understood, Niyati?
Yes, sir.
ठीक है. Next, write down thermal stability. Write down. Thermal stability means what? Stability towards heat. Write down, it decreases down the group since the bond length increases. It decreases down the group since the bond length increases. NH3 maximum, pH3, okay. Now on the basis of this, we can also define the reducing agent behavior. The reducing agent, we write down. The behavior as a reducing agent decreases down the group. NH3 is the most powerful reducing agent. Then we have PH3, ASH3, SBH3, and then BIH3. So what happens in this? Thermal stability decreases. It means it can easily lose H plus ion, hydride ion, right? So write down into this. Oh, order I have written ulta na. Down the group go, thermal stability decreases and tendency to lose hydride ion will be more, na? So order is this. So except NH3, all are good reducing agent. See, actually reducing tendency, write down. The reducing tendency is the ability to give hydrogen, or hydride ion also you can write. So as you go down the group, thermal stability decreases. It means it can lose hydride ion easily and hence good reducing. Okay. We know NH3 ammonia is a base, correct? Right?
Yes, sir. Weak Lewis base.
So we can define basic character also. Basic nature is the tendency to lose electron pair, right? Tendency to lose electron pair. So as the size increases, electron density decreases. Electron density decreases means tendency to lose electron is less, and hence the basic nature decreases. So basic nature is maximum for what?
Ammonia.
Basic nature is maximum for NH3 because the electron density is maximum. So basic character of the hydrides of group 15 down the group decreases. Right? So NH3 is the strongest base NH3 is the strongest base. Then we have pH3. All other hydrides are not basic at all. They do not have tendency to lose electrons. Okay. To write down the order, I have written this way. But these are not basic. Next, write down solubility.
Solubility in what, sir?
Solubility in any solvent, like water or the solvent. Write down.
Okay. I thought it would be different.
Write down. Ammonia is soluble in water. Ammonia is soluble in water because of hydrogen bonding. But other elements, hydrides, are insoluble. But other elements, hydrides, are insoluble. Chalega?
Yeah, sir.
So we are done with hydrides. Okay. Next, we'll see oxide formation. Second one. Just a second. Write down. The elements of group 15 forms large number of oxides. Forms large number of oxides. Nitrogen forms multiple bonds with oxygen due to its small size. Nitrogen forms multiple bonds with oxygen due to its small size, but other element does not form multiple bonds. Properties you write down. The oxides of nonmetals are acidic. The oxides of nonmetals are acidic, and those of metalloids are amphoteric. and those of metalloids are amphoteric, while those of metals are basic. Okay, non-metal acids, metalloids amphoteric, and metals basic. Second point, greater the electronegativity difference, more acidic the oxide is. Okay. Write down. Among the oxides of same element, these are few general properties you should know. Okay. We'll see one by one what all oxides we have. Among the oxides of same element, acidic strength increases with percentage oxygen character. Percentage,
Season, sir.
not character. Acidic strength increases with the increase in oxygen atom. Or we also say increase in the percentage of oxygen.
Oh, NO3 is greater than NO2, like that, sir.
Like that, yeah.
Okay, sir.
Oxides of same element, as the percentage of oxygen increases, then the acidic nature increases. This point is important, okay? On this, they have asked question also. So suppose you have to compare the oxides of nitrogen like N2O, right? Then NO, then NO2, NO, then N2O3, then N2O4, N2O, O5. Okay. Order of acidic behavior is this, since the percentage oxygen is increasing. Write down, these elements forms two types of oxides, trioxide and pentoxides. These elements forms two types of oxides, trioxides and pentoxides. Okay, trioxides and pentoxides. The acidic strength of these oxides decreases down the group. Decreases down the group. Okay, so if you compare the trioxides and pentoxides, for example, N2O3 is most acidic, then P4O6 dimer of it, then we have AS4O6, SB4O6, the acidic strength. And same thing we have for pentoxides, N2O5, P4O10, AS4O10, and SB4O10.
Sir, why do they dimerize, sir? So why exactly do these guys dimerize?
See, actually, when you talk about P2O3,
Yes, sir.
So P2O3 is not that stable. It's not the stable structure.
Why, sir?
When they dimerize, the structure becomes symmetrical and the energy decreases. And
Okay.
this dimerization takes place at normal temperature, means we are not doing anything into it. The energy
Okay, sir.
at normal condition is sufficient enough so that the exchange of electron takes place and the two such molecules combines together and gains a lower energy state.
Yes, sir. Got it, sir.
Okay, so this is the order. Now, like I said, nitrogen forms large number of oxides. So we'll discuss one by one those oxides. We'll finish it here only. Okay, so first oxides of, write on the heading, oxides of nitrogen. Oxides of nitrogen. First one. Write down dinitrogen monoxide. What is the formula?
No2. N2O.
Oxidation state of nitrogen.
-1.
Who's the examiner? And
+1.
you got -1.
Sorry, sir.
This we also call it as nitrous oxide, which we also call it as okay, near the NH3, I did not see this question. Well, NH3 is most basic because you see, NH3 is the smallest size, no? So the electron density of this electron pair is maximum here. That's why it can donate the electron easily. Right? More electron density, more will be the tendency to lose electron and hence the more acidic. Okay. Okay. The next is, why does the acidic strength of oxides decrease down the group? Any answer for this? Why does the acidic strength of oxides decreases down the group?
Sir, can we describe acidic strength as ability to release H plus?
No, in this one we do not have what hydrogen. No.
Okay. H plus as in the electropositive atoms. Oh no, sir.
No.
Nothing. I'm wrong, sir. Wrong.
No, we cannot do that. See, one point I have given you already. That's why I asked. Greater the electronegativity of the element, more acidic the oxide is.
Oh yeah, more non-metallic it becomes. Correct.
Right? So as you go down the group, the acidic strength the electronegativity decreases, right? Metallic nature decreases. And
Increases.
basic nature increases.
Yes, sir.
Hence the basic nature increases. Correct. In fact, the oxides that I have given you, AS4O6 and SB4O6, those two are amphoteric in nature. Write it down. AS4O6 and SB4O6, the order there only you write down, is amphoteric. Bi2O3 is basic. Got it, Niyati? Okay. Okay, coming back to this point, dinitrogen monoxide oxidation state +1. So you should know the oxidation state. You should know the preparation method. The preparation method is what? When you heat NH4NO3, I'm writing it down quickly. You also copy it down. When you heat this at 250 degrees Celsius, you will get N2O and H2O molecules goes out. We can also obtain this by hydroxylamine, NH2OH plus HNO2, nitrous acid. And when you heat this mixture, you will end up getting N2O and H2O.
So these questions come a lot in exams.
Yes.
Like direct they'll come, and all of us will flunk. I especially flunk it.
That's why it's very important. You have to memorize this. And see,
Okay,
this
sir.
kind of questions you can do in a second, right?
Yes, sir. Very high investment returns.
Correct.
So could you go back, sir? 1 minute.
No return when I go. There's no investment.
Okay, sir.
This one.
Yes, sir. Just a second. Done, sir. So what happened to bismuth oxide here?
You can write that. Basic.
Okay. I'll write that at the end, sir.
Write down.
And that's also dimerized. Bi4O6, Bi4O10.
Has tendency time.
Okay, sir.
Property won't change.
Okay.
Okay. So this is the preparation reaction we have. Properties are what? It is colorless, and neutral. No charge on this. Okay, and when you heat N2O, this reaction is also important. At around 600 degrees Celsius, it gives us nitrogen and oxygen. चलेगा?
Yes, sir.
ठीक. Okay. The structure of N2O, you see. N2O structure we can draw like this: N, triple bond N, and a coordinate bond with this oxygen. One lone pair, like this. And one lone pair we have here. Two lone pair we have here. Okay. This is one structure you can draw, or we can also draw this bond as this. Negative, this is positive, and one lone pair. This also you can draw. Okay. So sometimes they ask this question: how many lone pairs are present? Right? How many lone pairs are present?
Yes, sir.
That also they ask sometimes. Okay. Second oxide you write down nitrogen monoxide.
Tear gas, right?
Huh?
Is this tear gas, sir?
No, it's not.
What is tear gas?
What is the formula of tear gas?
I
Nitrogen.
don't know here.
What we call it as all? We also call it as nitric oxide.
No.
Yes, monoxide is NO.
Yes, sir.
Okay, NO is the nitric monoxide, nitrogen monoxide, or we also call it as nitric oxide, NO. Okay, so here you see the oxidation state of nitrogen is what? Tell me.
+2.
Oxidation state is +2. And how do we prepare this? It is prepared by the reaction of metals like copper on reaction with HNO3. But this should be dilute. Reaction of HNO3 is very important. It gives different products when it is dilute, concentrated, or very dilute. Okay, so we'll see those reactions also. Forms NO plus Cu NO3 whole twice. What is the oxidation reduction potential of copper?
Sir, something. One sec. Check it.
0.34. 0.34
Positive, right?
positive.
It can reduce hydrogen easily.
Yeah.
That's what it is doing here. It displaces hydrogen from its acid.
So there's actually a thing called dilute, concentrated, and very dilute.
Yes.
What is the difference, sir?
We'll discuss that. Alright.
Okay,
500 ml water लो, उसमें 100 ml HNO3 you put.
Okay.
That is one solution, correct?
Yes, sir.
Up in the 500 ml water, may you can put 50 ml of HNO3. Then this 50 ml wala solution is dilute.
Yeah.
100 wala is comparatively concentrated.
Yeah.
Ab 1 ml डाल दो, that is very dilute.
Yes, sir.
What is this?
I mean, yeah, but
Yes.
okay.
So the another method of preparation is reaction of NH3. See, I'm writing down the balanced equation, but this balanced equation is not required. You should know what product is forming. Platinum is the catalyst we are using. Oxidation of this, it gives NO plus H2. Just a second. Okay. Okay, this is the reaction by which we can prepare this nitric oxide. See, this is a colorless gas, but in solid and liquid state, it shows blue color. Write down. Colorless gas, but in solid or liquid state, it shows blue color. When you heat this at around 100 1100 degrees Celsius, higher temperature, it converts into N2 and O2. When it reacts with O2, it converts into 2NO2. Nitrogen dioxide. Done?
Done, sir.
Okay, now the important thing here is the structure of this. The structure of NO. First of all, you tell me how many electrons this NO has? "15 electrons, right? You see, it has odd number of electrons, hence it is an odd electron molecule.
Yes, sir.
What?
I told yes, sir.
It is an odd electron molecule since it has 15 electron. So odd electron molecules means we have one bond, one electron bond is an odd. See, actually what happens in one single bond, usually we assume what there are 2 electrons present. But in odd electron, what happens? In odd electron, there is 2 types of electron possible. One odd electron bond is the bond in which only 1 electron is there, and another type in which 3 electrons are present like this. So these 2 are odd electron bond. Single electron bond and 3 electron bonds are odd electron bond. Right. So this you have to memorize, that in NO molecule, there is a 3 electron bond. There is a 3 electron bond present. 1 lone pair on oxygen and 1 lone pair on nitrogen. Okay. You can find out the bond order of this with the help of what? With the help
That 1s2 sigma, 1s2 sigma star, 1s2 and all.
MOT, molecular orbital theory. Okay, just you know, fill the orbitals with electrons, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, and you can find out the bond order. Okay,
Half of bonding minus half anti-bonding.
what?
Half bonding minus half anti-bonding.
Yes. So odd electrons are considered as half bonds. Okay. So for this NO, the bond order you'll get 2.5 according to MOT. And that 0.5, to define that, we have this kind of structures, this kind of bonds. So 0.5 signifies what? Half electron. Half electron bond means, sorry, half bond. Half bond means odd electron bond. Odd electron bond means what? Either single electron bond or 3 electron bonds. Okay. So in NO, we have 3 electron bond present. Okay. So this NO is, since we have odd electron, so it is what? It is paramagnetic. It is paramagnetic. Second thing, and paramagnetic in gaseous state also, you write down. In gaseous state. But in solid and liquid state, what happens? It dimerizes, write down, in solid or liquid state, it dimerizes and converts into diamagnetic. Okay.
And that electron you got is what gives it the color, sir.
What? Yes, yes.
So 1 minute, can you go back in solid? Structure. Ayo, 1 sec, sir.
See those stuff where we have nitric acid preparation properties, okay, like we have phosphine preparation properties. Those stuff are given in NCRT also, so you can go through that.
Okay, sir.
I think this oxide part is not given in us NCRT in that detail. Okay, that's why I'm
Okay, sir.
detail I'm discussing it. Okay.
Yes, sir.
So nitrogen monoxide is this. The next thing you write down, the third type of, I have given you the structure of this. Yes, structure is given, reaction is given, properties. Okay. The next one you write down, we have dinitrogen trioxide. Third one.
N2O3.
Yes. That is N2O3. Dinitrogen trioxide. Tell me the oxidation state.
+3.
+3. Is it +3
Yes, sir.
on each
Yeah,
nitrogen
sir.
atom? -2, -6, so +3 we are getting. Fine, it's not on each nitrogen atom, but +3 oxidation state we have here. Structure we'll see for this. Okay. It forms by this reaction. Preparation, the first one, the reaction of NO and the reaction of NO2 gives N2O3. Okay. In solid and liquid state, it is blue in color. It is blue in color. But in gaseous state, I'll write down this by reaction. N2O3 in gaseous state, it exists as the mixture of the two gases from which it has been formed, NO2 and NO. One information is most important over here. Write down in concentrated H2SO4, in concentrated H2SO4, the blue color disappears due to the formation of nitrosonium hydrogen sulfate. Means we get nitrosonium ion NO plus and we get hydrogen sulfate ion also, HSO4 minus plus H3O plus. Okay, sometimes they'll ask you this, that due to the formation of nitrosonium ion, its blue color disappears. The same thing happens, the disappearance of blue color also takes place in moisture. Write down, in presence of moisture, blue color disappears okay, blue color disappears due to the formation of nitrous acid. What is the reaction? Nitrous acid, what is the formula?
NO2.
HNO2.
Yeah, that's what. NO2.
What NO2?
NO2. NO3. No2 clo2. NO2.
Right? It is an acid, right? Nitrous acid. And hence we also say that the aqueous solution of this oxide is acidic in nature. Right now. Aqueous solution of this oxide is acidic in nature. The structure you see. Coordinate bond, double bond O, and we have double bond O, and we have a double bond here. Each oxygen atom bonded with double bond has 2 lone pair. Nitrogen has 1 lone pair. The one which is coordinated bonded with oxygen has 3 lone pair. Okay. If you write down one single bond here, the nitrogen will have positive and this oxygen will have negative charge. And you see this lone pair is present over here, but actually this pair of electron is donated by the nitrogen. So I should write it here. Lone pair, this coordinate bond we have. 1 pair of electron comes from the nitrogen. So this is the structure. Dinitrogen trioxide. The third one, I write down nitrogen dioxide, NO2. Oxidation state +4. Right? Preparation is done by when copper is allowed to react with HNO3. NO2 plus CuNO3 whole twice plus 2H2O. Okay. Remember, in the preparation of nitrogen monoxide, we have had the same reaction, right? But there the HNO3 is what? It was dilute, but here it is concentrated. That's why you see when concentration changes, the oxide also differs. This question they have asked many times. What nitrogen oxide evolves in this reaction? Right? So depending upon the concentration, we will have the different oxides of nitrogen.
So just a second, sir. I think I made a mistake in structure of N2O3.
We can also obtain this by NO with
Sir, you're laughing, sir.
This is the reaction. Lead nitrate, if you heat. Done, Venkat.
Sir, you turned, sir.
You want me to go back?
Yes, sir.
बोलोगे ना? Just a second. You said
No,
this.
sir, I kept asking that, so I wanted to convey in a different way, so that
Now
diplomacy skills.
Okay. So this last page you want me to?
Yes, sir. I thought it'll be very subtle, diplomatic, and all.
Then that is not required. Long time. Oh, you're done?
Yes, sir. Thank you, sir.
Write down this 3 reaction.
Written, sir.
NO2.
Count I didn't write. That I'll write. Now up to date. To underline, sorry.
Okay. Color is brown. Right, brown color. And this is also paramagnetic. Why paramagnetic? You can tell me. Why
The
is it
nitrogen oxygen coordinate bond. Nothing.
because it has odd electron. NO2. 17 electrons it has.
One sec. 14. 1, 2, 3, 4,
That's
5,
6
6,
into
7,
2,
8.
12. 12 plus 5 is 17.
12, yeah. Yes, sir.
Okay, paramagnetic.
Yes,
Acts
sir.
as an oxidizing agent. Oxidizing agent, for example, 2Cu plus HN, sorry, why I have written HN, NO2. So what happens? This will oxidize Cu into CuO, 0 to plus 2, plus NO, monoxide. Same happens with carbon. Carbon, it forms carbon dioxide. With the higher oxidizing agents like O3, NO2 forms higher oxides like N2O5. So here you write down for this reaction, you write down here. With strong oxidizing agents, O3 is stronger. With strong oxidizing agents, this forms higher oxides, N2O5. Okay. Write down, it also has tendency to dimerize and forms N2O4. Tendency to get dimerized and forms N2O4 and becomes diamagnetic.
Very intelligent compound, sir.
Done?
Yes, sir. Done.
N2O4, the structure is this. Oxygen with double bond, 2 lone pair. Okay. This is a structure possible. Remember, wherever I have drawn this coordinate bond, you can also draw a single covalent bond. But in that case, we'll have charge on the atom then. Correct. Now, suppose if I draw the resonating structure of this one, this lone pair comes over here, this pi electron shifts over here, and this will be what? N double bond O. Single bond O. minus, and here we have plus, minus, and here we have plus. This way also you can draw. Clear?
Yes, sir. Sir,
Hmm.
two things. Here, like when you do the resonating structure, there are 8 electrons now, sir, in oxygen, 8 electrons and 8 dots and 1 negative charge.
Where?
Here, oxygen. Left side oxygen, left side bottom.
This one.
Ah, yes, sir. 1, 2, 3, 4, 5, 6, 7, sir.
2, 4, 6, and 2, 8.
Ah, okay, okay. No, next to that negative charge looks like one dot, sir.
No, it's negative charge.
Yes, sir. Okay. 1, 2, 3, 4. And sir, another thing, can a coordinate bond and another covalent bond exist together, like side by side?
What?
In any compound, random compound, can a coordinate bond and a covalent bond exist side by side, like parallel to each other? Like,
Possible.
oh, okay, sir. Like in what, sir?
Coordinate bond. This is the example. This one is covalent and this one is coordinate. Oh, you are saying
No,
same atom.
like equal to, you're writing equal to, no, sir. One of the equal to make it arrow.
Can say that. We represent that with the third period element. See, coordinate bond nowadays, it is considered as the covalent bond only. Type of covalent. The
Okay,
arrow
okay, sir.
definition is the old definition we have.
Okay.
But it is not wrong. New definition is we consider coordinate as the covalent bond only.
Okay, sir.
See, actually what happens, how coordinate bond forms.
It donates and then shares.
देखो अगर NH3 है, we have suppose NH3 has lone pair and H plus घूम रहा है इसके अगल बगल. This H plus requires this electron because the electron deficient, correct? So the old definition was that this donates its lone pair of electron and forms a bond, and the bond is this, which is the coordinate bond, correct?
Yes, sir.
But now how do we define this? In nitrogen first gives its one electron only to this hydrogen.
Oh.
Right,
Side.
and make the hydrogen neutral.
Okay, sir.
Electron दिया, neutral बन गया, and then it shares the electron. One electron it shares. So this is the new definition of coordinate. So in this case, what happens? It becomes positively charged again because 4 bonds are there.
Oh, okay. Yes, sir.
Nitrogen has 5 electron. 1 electron ये hydrogen दे दिया, so positive charge.
Yes, sir. Okay, sir. Got it.
Fine. Next one is N2O4. Just now we have seen the structure of it. Oxidation state is +4. We also call it as nitrogen, dinitrogen tetroxide. Dinitrogen tetroxide can be obtained by NO2 when you cool this. On cooling, 2 moles of this converts into N2O4. Okay. Its aqueous solution is also acidic because N2O4 in water, it forms 2 different acids, that is nitrous and nitric. Nitrous and nitric. N2O4 structure we have already seen. Sixth one you write down. It is dinitrogen pentoxide. Which is N2O5. Could you tell me the oxidation state?
Minus 2.5 plus 2.5.
The state of nitrogen is +5 here. It is obtained by the reaction of HNO3 with P2O5, and it forms an N2O5.
Sir, it can be it's plus 5 by 2, no, sir?
Hmm?
Oh, plus 5, nothing. I don't know math, sir.
4AgNO3 reacts with Cl2, forms AgCl, N2O5 forms an O2 oxygen. Okay. Next, write down the properties. In gaseous state, N2O5 has NON bond. Means the 2 nitrogen atom is attached with 1 oxygen atom.
It has a non-bond. Non-bond. Nice.
Okay. It exists as NON bond, which we call it as oxygen bridge. In solid state, in solid or gaseous state, it exists as a mixture of N2O4 and O2. N2O4 and O2. One reaction you write down. N2O5 plus water H2O gives 2 moles of HNO3. Gives 2 moles of HNO3. Right? And hence N2O5 is known as anhydride of HNO3. Anhydride of HNO3 is known as anhydride of HNO3, and the aqueous solution of this oxide is acidic in nature. Okay. N2O5. The structure is similar to N2O4, just the 2 nitrogen atom is attached with the oxygen atom. So the structure goes like this: NON, oxygen double bond O, oxygen double bond O. Lone pair, the number of lone pair they ask in this, that's why the structure is important. Okay, once you know the structure, you can do all this. 1, 2, this, This is the structure. Okay. Okay. This is it for the oxides of nitrogen. One more comparison we have of bond angle that we'll see after the break. Okay.
Okay, sir.
Yes, sir.
We'll get back at 5.
Okay, sir.
Chalo, take a break.
Yes, sir.
Hello?
Hello, sir.
Yes, sir.
Yeah. So, yeah, we have discussed about oxides, okay? One important comparison we have of bond angle, okay, based on VSE-PR theory, valence share bond pair, like electron pair repulsion theory, that is, no, repulsion in lone pair and bond pair. Okay, so we have the order of bond angle, this we write down. It is maximum for NO2 plus, then we have NO2, NO2, and then we have NO3 minus, NO2 minus, and NO2 minus. Could you tell me the hybridization of all these molecules interlateral?
Yes, sir, but it'll take time. 2 minutes, sir. Sir, is it okay if we tell you the method?
No, method I know.
SP.
What about the first?
2.5, 2.
What two?
First one is SP.
SP.
Yeah. So that's 3.
This one?
So NO2, right? N oh,
Of?
NO2 plus. Okay, so sigma.
We are getting 17 electrons, right?
Yes, sir.
We have 2 bond pair and 1 unpaired electron. So that also we count into this. Hybridization will be sp2. This one, sp2. This one, sp2. 2 bond pair, 1 unpaired electron, single electron. 3 bond pair, 2 bond pair, 1 lone. Okay.
Yes, sir.
So first of all, you see, all are sp2, correct? So we have to find out the bond angle with respect to the respective repulsion. Here we have single electron and bond pair. There we have only bond pair here. Here we have 1 lone pair and bond pair, correct? So here, because of presence of lone pair, the bond angle will be minimum, right? This 1 lone pair and there is no unpaired electron here, this won't produce that much of repulsion, and bond angle here, it is more in case of this. Exact value of bond angle here, it is around 134 degree. This is 120 as it is sp2, no lone pair. We have 1 lone pair here, so the bond angle reduces to 115 degree. Right, so little bit idea you can have with the help of hybridization, and then lone pair, bond pair repulsion, you can have this idea. Okay, so NO2 radical, this one you must remember the bond angle here. Done?
Yes.
Done.
Okay. Okay. Next, you see the oxides of phosphorus. Just we have to see the structure of it. The different oxides of phosphorus we have P4O6, we have P4O8, P4O10. In this structure-based question they ask, and they ask you how many POP bonds are there, How many P double bond O bonds are there? How many bond pair lone pairs are present? This kind of question they ask. Okay. So here you see P4O6, the 4 phosphorus atom present like this at 4 different corners. It is present like this. And each phosphorus atom is attached with one oxygen like this. One oxygen in this, one oxygen in this.
Then in the middle will come.
Like this it is.
Outside.
You see each phosphorus atom has attached with one oxygen. Each oxygen atom has 2 lone pair and phosphorus has 1 lone pair. So if you know the structure, you can find out the number of bonds, POP bonds, number of lone pairs, number of bond pairs, anything you can find out. This is P4O6. Now in P4O10, what happens? In P4O10, sorry, O8, we have 2 more oxygen here, right? So with this, any 2 phosphorus atom attached with an oxygen with a coordinate bond, oxygen attached with it. Okay, so for this one, the structure is
Two bridge oxygens, I guess.
like this, and any 2 phosphorus has 2 oxygen present. Like this. There's no lone pair on phosphorus because it has donated to this oxygen atom. Could you draw the structure of this one, O10?
Sir, any 4 coordinate bonds? Like all 4 coordinate bonds?
More we have over here and the structure.
Sir.
Draw that one also.
Yes, sir. Wait, sir. 1 second, sir. I am done that one.
Done?
Done.
No, sir.
Why?
Drawing, sir.
Done.
Okay, next you write down halides. The element of this group forms 2 types of halide, 2 series of halides. Okay, trihalides and pentahalides.
Pentahalides.
The element of these the element of this group forms two series of halides, trihalides and pentahalides. Okay. One note write down after this. Nitrogen does not have d orbital. Nitrogen does not have d orbital.
So can't form pentahalides.
Since it cannot form pentahalides. Right? So nitrogen does not form pentahalides, but all other elements forms pentahalides. Okay.
Sir, by d orbital you mean even vacant d orbital counts, no sir? Because
Vacant d
phosphorus.
orbital. Then only it can accept electron.
Yes sir.
Trihalides. For trihalides, we have metal, any element you take, and this is allowed to react with halogen directly and forms MX3. But here we have excess of metal and limited supply of halogen. If you give this halogen in excess amount, right, you will end up getting pentahalides. Okay, trihalides.
A mixture of tri and pent. Oh, okay.
No, with all that tri converts into penta.
Okay, sir.
Okay, the structure of pentahalides, you see, it is similar to hydrides, 3 halogen atom and 1 lone pair present. This is trihalides. What is the geometry? Geometry?
Tetrahedral.
sp3. Geometry tetrahedral. Shape?
Triangular planar.
-1.
Wait, how? Sir, remove the top of tetrahedron. What do you get?
You'll get pyramidal.
Yeah.
What? Yeah.
Tetrahedron is that one. Yes,
This
sir.
is in different plane above this triangle, and then lone pair.
Oh. Yeah, I thought that.
Okay. So sp3 hybridized, shape is pyramidal, geometry is tetrahedral. Right? Write on the bond angle of trihalides of an element. The bond angle of a trihalide of an element increases with decrease in electronegativity of halogen atom. Right? So if you compare the bond angle of PF3, it is lesser than to that of PCl3, then we have PBr3, and then we have PI3.
Sir, like if it's fluorine, then it should have more, no, sir? Then because small size will triple and all.
No. See what happens.
Oh.
It is just ulta of that. There we have, see, its central atom electronegativity is more. You
Yeah.
want to talk about the bond angle of NH3 and PS3, etc. Correct?
Yes, sir.
Here we have electronegativity of central atom is more than the bond angle. But here what
Yes,
happens,
sir.
the outer atom is more electronegative. You see this PFCN3.
Yes, sir.
So when outer atom electronegativity is more, this bond pair of electron is shifted towards the more electronegative element, right? And hence what happens? The distance between the electron pair increases. So less repulsion, bond angle decreases.
Oh, yeah.
But if it is other way, if the electronegativity of central atom increases, like suppose we have this one, nitrogen is more electronegative, then what happens? This
Electrons
bond,
get pulled and more repulsion.
now these two pair will fight,
Yes,
right?
sir.
They'll start fighting and eventually they'll compromise.
Yeah.
Okay, and we'll have a fixed bond angle. So if the electronegativity of central atom increases, bond angle increases, right?
Yes, sir.
Electronegativity of central atom increases, bond angle increases. Electronegativity of outer atom increases, bond angle decreases. Right, that is what we have.
Yes, sir.
Okay, so for any elements, trihalides of any elements, the order is like this one. Okay, properties write down. All trihalides are predominantly covalent. All trihalides are predominantly covalent. Trihalides are predominantly covalent. And their covalent character decreases down the group. Size increases, covalent character decreases.
So what, sir?
Covalent character increases down the group, and trihalides are predominantly covalent.
Ah, yes, sir. Wait, covalent increases down the group.
Yes,
Yeah.
because size,
Yeah, yes, sir.
covalent decreases.
Covalent increases down the group.
Covalent decreases, ionic characteristic. When size decreases, right,
Yes,
that
sir.
produces more polarization.
Yeah.
According to Fezan's rule, more polarization, more covalent nature. So down
Wait, so
going, size is increasing, polarization.
yes, sir.
Less polarization means less covalent, more ion.
Covalent decreases down the group.
Yes. So down the group, if you go, covalent nature of these trihalides decreases, ionic character increases.
Ah, yes, sir.
Write down among the trihalides of nitrogen, only NF3 is stable. Only NF3 is stable because of high bond strength. Okay. Among trihalides of nitrogen, the Lewis basicity increases down the group. Means for Ni3 it is maximum, right? Lewis basicity increases down the group. This is because the decrease in electronegativity. Minus I effect is less. Did you understand this comparison? Suppose we have NF3, NCl3, NBr3, and Ni3. All these nitrogen atom has lone pair. So basicity is tendency to donate this lone pair of electron. 3-fluorine atom most electronegative, maximum minus I behavior here, then here, then here, and then here. So least minus I, more basic the compound is. The order of Lewis basicity is this. Okay. Next, write down pentahalides. Write down the elements of this group reacts with halogen, excess amount of halogen, and it gives MX5, pentahalide. Pentahalide, the hybridization is sp3d. Okay, sp3d. And the geometry is trigonal bipyramidal. Bipyramidal. Structure, if you see, okay. Here we have metal. So phosphorus is present here, and the 3 halogen atom will be at the corner of this triangle, X and X, and 1 halogen atom here, another halogen atom here. This bond we call it as axial bond. There are 2 axial bond and 3 equatorial bond. This one is equatorial. Axial bond are the weaker bond in comparison to the other 3, right? Hence, these 2 bond we can dissociate. So when you heat this, suppose we have PCl5 When you heat this, so it easily converts into PCl3 and Cl2 goes out. These two chlorine are the axial bond chlorine we have. Okay, so structure is trigonal bipyramidal. Hybridization is sp3. And I've already told you that hydrogen does not form pentahalide because of unavailability of d orbital. Okay. Now phosphorus pentachloride, PCl5 if you see, write down the heading. Phosphorus pentachloride, write down. It can be prepared by the reaction of white phosphorus with excess of dry chlorine. Excess, this is white phosphorus. And forms 4PCl5. We can also take phosphorus trichloride for this reaction. With Cl2, it converts into PCl5. That is also possible. Next point, write down pentahalides. Pentahalides are thermally less stable than the corresponding trihalides. Less stable than the corresponding trihalides, and it can easily converts into trihalides on heating. And it can easily converts into trihalides on heating. See, all these structures that I have given you, the trigonal bipyramidal structure, this structure is true. This structure is true in gaseous state. Right? In gaseous state. In solid state, PCl5 exists as ions. Right? In solid state, it exists as ions, which is, it get dimerized actually, and it forms P2Cl10. So it will be PCl4 plus and PCl6 minus. Since in solid state, it exists as this.
Why, sir?
See, in solid state, what happens? First of all, it get dimerized, right? So this bond, phosphorus and phosphorus, are linked in this solid state. We have this structure, we call it as P2Cl10 get dimerized, and this is the structure we have. So what happens here? The one phosphorus atom will have this two halogen plus the other two halogen, which is there in other PCl5 molecule. All these four halogen with phosphorus forms one part of it, that is the anion. And these three halogens, X here, with the another three halogens, 6 halogen total, this forms the another part of this, that is cation. Oh, other. Because you see, the reason is what? This bond is weaker, axial.
Yes, sir.
So this X minus and X minus can come out easily. X minus and
Yeah.
X minus. Okay? Forms
Yeah.
some positive ions onto this phosphorus.
Yes, sir.
Right? Now this is associated with another 3 chlorine atom because it can show it's a hypervalent atom, can show more than 8 electrons, like can have more than 8 electrons. Other what we can say halogen atom combines with this and forms this P6 because it accepts X minus and X minus, one negative charge.
Okay, sir.
Minus goes out, and the other molecule we have px2 and plus 3, which takes this 2x minus, forms PCl4, one positive charge on it, loses 2 electron but gains 3 electron with this 3 halogen atom, so one negative charge. Okay, that's why it forms a square bipyramidal structure. Actually, I have written in this form, but it is actually very complex structure we have of square bipyramidal one ion like this, and we have the another one which is a tetrahedral structure, another ion like this. Because all the
Okay, sir.
fluorines arrange themselves in two different geometry, we can say. One is tetrahedral geometry, other one is square bipyramidal geometry, right? And with this arrangement only, the overall energy of the system of the molecule decreases maximum and becomes most stable. Because
Yes,
in
sir.
solid state is what? It is nothing but the arrangement of atoms. Correct. So we have two different parts. On this only, they have asked question in JEE exam. We have two different parts here. One is tetrahedral part, another one is
Square bipyramidal.
octahedral. Tetrahedral plus octahedral. Octahedral is the anion, tetrahedral is the hydrogen.
Okay, sir.
All these actions basically takes place to gain the most stable state. Okay.
Got it, sir.
Next, you write down metals. We don't have to do, but trihalides we have done. Okay. Next, you write down oxo acids of phosphorus. Oxo acids of phosphorus. I haven't done preparation of nitrogen, preparation of phosphorus, and the compounds of phosphorus like phosphine and HNO3. Okay, that I am not doing today. I want you to read those things from NCRT. It's not like I won't do, I'll do that in the next class. I'll go a bit faster into that because I feel
Okay,
it's
sir.
enough given in NCRT. So you read out once and then next class we'll do that quickly and move on to the next group, right? So next you write down oxo acids of phosphorus. See, actually oxo acids of phosphorus. See, actually, what are oxo acids first of all? Oxo acids in which the elements, any oxo acids, apart from oxygen and hydrogen, it contains third type of element also. Like here we have phosphorus, oxygen, and hydrogen. Okay? Generally, oxides of any element, what happens? We have NO2, N2O, N2O4, N2O5, etc. Right? But oxo acids are the oxides. It's not the oxides, but it is the compound of any element which contains oxygen and hydrogen with it. Right? we can also define this in other way. If any compound contains third type of atom other than oxygen and hydrogen, that compound is the oxo acids of the third particular compound. Like for phosphorus, it is S3PO2. We have hydrogen, phosphorus, and oxygen. Oxo acids of phosphorus, S3PO3, S3PO4, H4P2O7, many. Okay. So here also they'll ask you the question based on their structure. Okay. Now write down the heading first of all. Oxo acids of phosphorus.
Sir, can we also define oxo acids as central atom, oxygen, and then hydrogen, like standard structure?
That's a common thing in all the structures.
Yes, sir.
Okay, Aaron, fine. Okay, write down okay, so oxo acids is this. Write down in oxo acids of phosphorus. In oxo acids of phosphorus, the phosphorus atom is attached with one oxygen, or write down like this, at least one oxygen with a double bond. Okay. Write down these acids are classified into two categories based on their oxidation state. These acids are classified into two categories. The first one, write down the acids in which the oxidation state of phosphorus is +1 and +3.
So +1, +3 respectively the categories, sir.
Just a second. Oxo acid, two different classes. One in which the phosphorus is in +1 and +3 oxidation state. The other one in which the phosphorus is in +5 oxidation state. +5 oxidation state. Okay. Now, 2-3 important points we have for oxo acids, which you should keep in mind when determining the structure. Venkat. The first point you write down into this: in all oxo acids, phosphorus is tetrahedrally surrounded by 4 other atoms or groups. Okay. All oxoacids, phosphorus is tetrahedrally surrounded by 4 other atoms or groups. Next, second point. These acids contains at least one P double bond O bond, at least one P double bond O bond, and at least one PH bond, POH bond, sorry. One P double bond O and one PH bond. Okay. Next point, third point. The oxoacids in +3 oxidation state the oxoacids in +3 oxidation state may have property to go under disproportionation reaction. What is disproportionation reaction?
Same thing, oxidized and reduced.
PH3 plus S3PO4. What is the phosphorus oxidation state here? Here? Tell me. +3.
-6 plus 3 plus 3. Yes, sir.
Here it is -3. Here it is plus
+5.
8 minus 3, 5. So the acids in which it is in +3 oxidation state, disproportionation reaction possible when you heat this. This is important. Now one more which is also very important point we have here, write down. Acids which contains pH bond the acid which contains pH bond behaves as reducing agent. Behaves as a reducing agent. Okay, now we'll look at some example and their structure. The first example we have H3PO2. H3PO2, the structure is any structure, any molecule we have, you first of all, you write down this. One P double bond O and one OH. This you can draw without thinking anything. Simply you draw this. Now, if you have any other oxygen present, attach that oxygen and hydrogen and with POH and when this phosphorus. If you do not have any oxygen, only hydrogen is left, then whatever hydrogen is there, you just attach those hydrogen directly with the phosphorus. This. Understood?
What, sir?
Suppose we have H3PO3.
They have another OH bond. That's it.
Now, Venkat, listen.
Yes, sir.
What we have to do, We'll draw one double bond O and one OH without any thought. आँख बंद करके ये ड्रॉ कर देंगे, ठीक है?
Yes, sir. Compulsory criteria.
Yeah. Do we have any oxygen left now?
Yeah, one more.
Where we have hydrogen also. So
Two
if
more, yes, sir.
oxygen and hydrogen is left, we'll attach one more OH like this.
Okay.
Do we have hydrogen?
One more, yeah.
Do we have oxygen?
No. Oh, that's it. Okay, sir.
Okay.
Yes, sir.
H3PO2, I'm coming back to the first one. We call it as hypophosphorus acid. Name is also important here. It is hypophosphorus acid. Phosphorus acid, also known as phosphonic acid. Mostly you will get structure based question. They can ask you oxidation state of phosphorus. Could you tell me the oxidation state here?
+1.
+1. How it is +1? You can
Oxygen.
substitute -2 into 4 in this the average wala formula, X wala formula. But with the structure also you can do this double bond. So here we have +2, +1, +3, -1, -1, so +1. Okay. No doubt. H3PO3, we call it as orthophosphorus acid. We call it as orthophosphorus acid. Or we also call it as phosphonic acid.
So both are phosphonic acids.
Huh?
Both are called phosphonic acids.
No. Oh, I've written it phosphonic. It is phosphinic, the first one is. Not phonic. It is phosphinic acid. Phosphinic, phosphonic.
Oh, okay, sir.
Oxidation state, could you tell me here? See, +2, +1, +1, +4, -1, +3. You can do this by the method, X method also we can do this. H3PO3, how do we prepare this? Just, it is also important for this, the preparation method. We can take P4O6 trioxide and hydrolysis of this H2O gives H3PO3. This is the preparation method. We can also take phosphorus trichloride plus H2O gives H3PO3 and 6HCl. So 3 we have, so 3HCl. Okay, preparation method of this. One more thing that I have already discussed with you last year. Since two hydrogen attached with the oxygen, so it is what? Dibasic. Can release 2
Oh, yes, sir.
Can release 2H plus. For this one it is
Monobasic.
okay. See, one more thing we can observe. The number of oxygen atom that you have, -1 is the basicity, right? 2 minus 1, 1 is the basicity. 3 minus 2, 3 minus 1, 2, dibasic. Clear? So basicity of these oxides also you can write It is the number of oxygen atom minus what?
1.
1. That
1.
also number of oxygen atom minus 1. So we have done 2 S3PO2, S3PO4. The next one is S3PO4, the third one. What should be the basicity of this?
3.
3.
3. 4 minus 1, 3. Let us understand the structure of this. Tell me, how do we draw the structure?
Double bond OH without opening our eyes, and then OH, OH, OH. That's it. Understood this concept, sir.
Correct. So you see the same
Yes.
thing you're getting also. 4 minus
Yes,
1,
sir.
3. And 3 is the basicity. So it is tri-basic. Oxidation state, you tell me? +2, +1, +1, +1.
Plus 5.
You can find out this oxidation state with X method also. Assume X and then we can do this. The name of this compound, we call it as orthophosphoric acid. Important, this one. It is orthophosphoric acid. Okay. Tribasic orthophosphoric acid. It can be prepared by the reaction of P4O10. Phosphorus pentaoxide. The previous one was phosphorus trioxide. Excess of water. When you dissolve this in water, it gives you 4 molecules of H3PO4. This is the structure we get. Preparation method is this. They can also ask you how many POH bond is present in this molecule. All these are structure-based questions. Once you know the structure, you can do all this. Okay. So 2, 3, 4. This is the fifth one. S3PO5. S3PO5. It is, the name of this compound is, could you draw the structure, Venkat?
Yes, sir. But I already suspect a problem, sir. There is one more oxygen than.
That's why I asked you to draw.
Yes, sir.
Okay, so this is different. It is peroxy acid. So peroxy acids are very important for any competitive exam, whether it is JEE, NEET, MITSAT, whatever. Right? Peroxy acids are very important here. It is peroxomonophosphoric acid. Even if it is peroxo, then also you can always draw P double bond O and POH. ये तो करना ही करना है.
Yes,
Okay?
sir. That I did,
We
sir.
have one more oxygen. So what I have to do, we have to draw a peroxy linkage like this.
Ah, yeah.
This is a
Sir, this name is even bigger than my name, sir. Done, sir.
What is the oxidation?
Preparation and all, sir.
Wait, what is the oxidation state? Could you tell me?
+2, +1, +1, -2,
Plus 7.
+2.
Huh?
So +4.
2, 3, 4, 5. और क्या है? 3.
Ah,
But in this one, if you do that X wala method, you will get it wrong answer. Why? Because we have peroxy linkage. You cannot assume -2 for this oxygen. Right? We have to assume -1 for this. So +2, +1, +1, +1, +5. That's why I always suggest to go via this structure method. Got it?
yes.
Okay, preparation कैसे करते हैं? Phosphorus pentaoxide लिया P4O10 in H2O2 and water. S3PO5. It is not important. बस एक reaction मैं लिख दे रहा हूँ. Preparation of this is not important. 4 molecules of this. And remember, in organic chemistry, a balanced reaction is not that important. You should know what product we are getting. Okay, next one. HPO3. HPO3, the name is metaphosphoric acid.
Sir, what exactly are these ortho, meta, para here, sir?
No, it's ये benzene वाला नहीं है, just a name.
Okay, sir.
Okay. So this metaphosphoric acid HPO3, again the structure for this, if you draw, the structure would be P double bond O, OH. ठीक है, ये तो होगा ही. We have one more oxygen. So one more oxygen will be double bond O, and H is not there. Right, this one. So what is the oxidation state here? If you see, it is
+5 again.
+5, and it is monobasic.
Yes, sir. One had.
Now this reaction is important. These are temperature dependent reaction. To prepare this, what we do, we heat orthophosphoric acid. We heat orthophosphoric acid at around 520 Kelvin, and this converts into H4P2O7. And H4P2O7 is pyrophosphoric acid. H4P2O7, which you further heat at 870 Kelvin, it converts into 2 molecules of HPO3. Okay.
It's a pyrophosphoric acid, sir. Okay, sir.
So we have 2 more types: pyrophosphoric acid, pyrophosphorus acid, hypophosphoric acid.
What are they, sir? Too much phosphorus today.
Pyrophosphoric acid is H4P2O7. H4P2O7 is prepared by, we know this, if you heat this at this temperature, we'll get this. This is the preparation method. What is the structure here? We have P double bond O, but when we have 2 phosphorus, both are attached with 1 oxygen like this. And after this, we have OH, 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 and OH. So you see it is tetra basic also. 1, 2, 3, 4. It is tetra basic. Oxidation state of each phosphorus is 2, 3, 4, and 5 plus 5.
Yes, sir. Sir, you told this during our childhood bridge course.
This one.
Yeah, you know the oxygen thing. Whenever 2 phosphorus and 1 oxygen is always linked like that in the middle of those.
Okay. So pyrophosphoric we have done. Next is pyrophosphorus. Almost we are done, just few more minutes. Pyrophosphorus acid. Pyrophosphorus acid, the formula is H4P2O5. H4P2O5, and it has again two P double bond O, P double bond O, P double bond O, and there is an oxygen with which the two phosphorus atoms are attached. So we have used three, one OH this side, another OH this side, and we have two more hydrogen. So one pH here and another pH here. Remember, I have already told you the molecule in which the hydrogen is directly attached to the phosphorus atom is a reducing agent. Correct? So this one is what? This one is dibasic. Chalega?
नहीं साहब, ये नोट बहुत पुराना हो गया.
What?
Nothing sir, joke.
So it is 2 plus 1, 3 plus 1, 4 minus 1. That is plus 3. Is it plus 3? This is also plus 3. Both you'll get plus 3. How do we get this? By the reaction of H3PO3 with phosphorus trichloride, PCl3. This gives you H4P2O5 plus 3 molecules of HCl. And the last one we have hypophosphoric acid. Hypophosphoric acid. Hypophosphoric acid is H4P2O6. H4P2O6, there is no phosphorus oxygen bond into this. Means P directly attach.
Ayyo.
So we have 4, so OH, OH, OH. So this kind of question also they ask in the exam. They'll give you 4 different, this thing, options, and they'll ask you which one won't have phosphorus POP bond, right? Which one won't have POP bond? So answer is this, +4 and +4. Actually, whatever we have done so far, only hypophosphoric acid we have in which we have PP bond is present. Yes?
Yeah sir.
Preparation you see. 2P red phosphorus we take plus NaOCl plus 2H2O. This converts into H4P2O6 plus NaCl. This is the preparation. Okay, done?
Yeah sir.
Okay, so
Yes.
your homework is, just a second. Your homework is, you need to read preparation of nitrogen, phosphorus, allotropes of phosphorus. Okay, nitrogen, phosphorus, then we have HNO3 and pH3. These 4 things you have to study from
1 sec.
NCERT. Okay? We'll see a few things into these 4 compounds next class, and then we'll move on to group 16.
Okay sir.
Okay, thank you.
Thank
Thanks
you.
sir.
Thank you, sir.
Thank you. Bye.
Bye sir.